Hi everyone, today I would like to give a presentation about the 5G new radio vehicle to everything communication. So for vehicle to everything communication, also called a V2X technology. Before I go to the detail about V2X technology, I want to first talk about why we need V2X. With the development of telecommunication, people went through the different stage of communication from just calling each other to send various information like text message, video, and different documents. With the 4G LTE network, what we can do is not just limited to certain applications. For example, online gaming, virtual reality, and autonomous vehicles. Vehicle to everything is one of the most important projects for LTE and especially for 5G. According to the WHO, each year more than 1.2 million people die in traffic accidents worldwide, with another 20 to 50 million injured or disabled through traffic accidents. Most of the accidents are caused by human errors, which is preventable if there exists a system to help people deal with this sort of situation while they're driving. This is the important reason why V2X should be invented. And V2X communication includes four subsystems: the vehicle-to-vehicle communication, vehicle-to-infrastructure communication, vehicle-to-network communication, and vehicle-to-pedestrian communication. In this presentation, there are three aspects I researched about V2X. First is the two communication method of V2X. First one is the dedicated short-range communication. The second is the cellular V2X communication. And then I will compare those two methods under the vehicle platooning condition. At last, I will talk about how 5G new radio can improve the cellular V2X communication. So for the DSRC is a wireless technology used for automotive and intelligent transportation system via a short-range exchange of information between vehicles and infrastructures, and between vehicle and vehicle. So DSRC technology can be used using transponders known as onboard units or the roadside units. As you can see on the figure, the DSRC can perform V2I and V2V communication. Another communication method is the cellular V2X communication. The cellular V2X communication has two types of method. The first one is the mode 3, which is base station scheduled. The second one is the mode 4, which is direct communicate. The left hand side is the mode 4, direct communicate. We can see the vehicles can communicate with each other directly via the PC5 interface. And the right hand side is the mode 3 communication. Mode 3 needs assistance from eNode Bs via control signaling over the UU interface to manage the V2V traffic and information exchange. Here are the pros and cons for DSRC and cellular V2X communication. We can see DSRC can work independent without the network coverage, and is a mature technique with low latency within short range. However, the communication time for DSRC is short while the two vehicles are driving very fast, and the hardware cost is very high in order to perform the DSRC communication. DSRC can only support V2V and V2I communication. On the contrary, cellular V2X communication has wide coverage range due to the base station and the high network capacity. It can support all of the 4 types of communication of the V2X. However, V2X, cellular V2X has high message latency. It's hard to keep high message reliability under a bad traffic condition, and the uplink transmission is very slow. Here is the platooning condition. Platooning is a group of cars which lay in one line and keep certain short distance between each car. To maintain distance between vehicles, the vehicle needs to share status information such as speed, heading, and intentions like braking, acceleration, etc. It uses cooperative adaptive cruise control to keep the distance between each vehicle, and the vehicle will broadcast cooperative awareness message to other vehicle to make communication. From this figure, we can see the vehicle at head of the platooning is called the platoon leader, which is responsible for platoon management, and the rest of the vehicle are called platoon members. They need to adjust their speed to keep certain distance from their preceding vehicle. Here is a brief description of how they communicate. The platoon leader should collect and update surrounding traffic information from the platoon member and report it to the roadside unit or the E-Node Bs. Depends on which communication method we are using. At the meantime, the E-Node B will send surrounding and far away traffic data to platoon leader, and then platoon leader will share those informations to all the platoon members. Here is the simulation of the platooning truck. The simulation scheme are described as the figure. We can see in a 4-line highway, 10 trucks form a platoon in one line with max speed 100 km/h, and there are non-platooned cars surrounding. The density of the non-platooned cars varies from 0, 5, 10 to 10 and 20. Under this condition, we have 3 performance matrices to determine which communication method is good. The first matrix is the average inter-truck spacing. The second is the CAM message latency, and the last one is the CAM reception rate. Here are the results of the simulation. By increased traffic density from 0 to 20, we can compare those simulation results for the inter-truck spacing, CAM message reception latency, and the CAM reception rate independently. So let's first look at the inter-truck spacing. As we can see, for DSRC, it has a very large variation from 0 to 20, and for mode 4, cellular mode 4, it has quite short variance from 0 to 20. For mode 3, it keeps 0.8 for the all traffic density. And table 2 represents the latency of CAM message. With the increase of the traffic density, we can see the DSRC has a very low latency, around 0.5 milliseconds. And for mode 4, it has quite slow latency, around 8 milliseconds. For mode 3, it has latency around 7 milliseconds. So DSRC has the fastest latency. The 3 figures at the bottom are the CAM reception rate. For the CAM reception rate, truck leader will broadcast CAM message to rest of 9 platoon members under 4 different traffic density. With DSRC communication, which is the first graph, we can see the cam reception rate is worse for the truck which are far away from the truck leader. As we can see, the number 10 truck is the farthest truck. And under the worst condition, which is the number 10 truck and 20 cars, which is the red line, the reception rate will drop below 85%. And for the second figure is the mode 4 communication. We can see it has the similar behavior like the DSRC, but with the higher cam reception. Even under the worst condition, the reception rate is around 90%. And for mode 3, it has the best performance. No matter which condition and how far of the truck between the platoon leader, the cam reception rate is almost 100. From the 3 measurement condition, we can see that although DSRC communication has the lowest cam latency, but it has higher inter-truck space and lower cam reception rate under high traffic density. Cellular mode 3 has the best performance with low latency, with high reception rate and very small interspace. So we should use the cellular V2X communication in the future to provide high reliability and low latency communication for V2X. Here's another method raised by another paper to create a better communication under the similar simulation condition like before. The previous method transmit cam message from platoon leader to each platoon members. However, for the new method, it allows platoon member to platoon member transmission and using dynamic scheduling instead of the semi-persistent scheduling. Because the dynamic scheduling has spatial frequency reuse, which allow 2 or more D2D transmission to be scheduled on the same resource blocks if their mutual interference is weak. So here is a simulation result. As we can see, by enable the frequency reuse, it can get a very high reception rate, almost around 1 compared to the disabled one, which is a green line. And it can have a very low completion time compared to the disabled one. So by using this method, we can further reduce the latency and get high reliability. 5G is an upcoming trend right now, because there are various IoT devices and different fields requires better network to support. For example, remote device, agriculture system, and public transportation services. Therefore, LTE network can no longer support that huge amount of network data rate with current network standardization. As a result, people are researching the 5G new radio network with new features to satisfy those network requirements at different areas. 5G NOMA is a new multiple access method for 5G. NOMA represents for the n-orthogonal multiple access. The key feature of NOMA is to serve multiple users at the same time or frequency. As we can see from the figure, the user close to the base station has the smaller power, and the user far away from the base station use more power. This can have a significant spectrum efficiency gain over the conventional orthogonal multiple access. Here is another simulation under a NOMA-based mixed, centralized, or distributed scheme, and apply power domain NOMA technique. Under this simulation, 20% are transmission user, 80% are transmission receiver user, and it allows most two transmitter user share the same subchannel. Here is the definition of the NOMA MCD scheme. At the beginning of each semi-persistent scheduling period, each vehicle user updates its position and velocity information to the base station. The base station then allocates the frequency resources to the transmitter to maximize the number of successive transmitted messages after the centralized spectrum assignment. Distributed power control coupled with transmitter and to receiver selection is preferred. The transmitter user adjusts their transmit power based on the feedback from neighboring receiver user. We can see here is the simulation result under the condition. We can have a high packet reception probability when using the NOMA MCD scheme compared to the conventional orthogonal multiple access method, and the low latency can also get by using the NOMA MCD scheme. So from both figure we can see the NOMA MCD scheme has the best performance for packet reception and low latency. So using the power domain NOMA, we can get low latency and high packet reliability further. As conclusion, I've talked about three main aspects in this presentation. First, two communication methods, and I compared those two communication methods under the vehicle plan tuning condition and get the conclusion of the cellular V2X communication should provide better low reliability and low latency and high reliability. And then I proposed a NOMA MCD scheme for V2X broadcast system, combining the centralized SPS at the base station and the distributed power control of the vehicles. In this way, we can get a UE latency. In this way, the UE latency will reduced and the reliability can be further improved. I hope you guys enjoyed this presentation. Thank you.